Okay, so the last time we left off with the properties of rational exponents. All of these properties you have seen at some point before, but we're going to look at them in a little bit more detail today. So the very first property we're going to look at is if we have something like a to the m times a to the nth. In this case, we have the same base for both of them, and when we're multiplying exponents with same base, we're basically just adding our exponents together. So for this first one, let's use the example 3 to the 1/2 power times 3 to the 1/2 power. What happens when we have an example like that? Well, since we have two exponents with the same base that we're multiplying, we can simply just add our two exponents together. So this would be the same thing as 3 to the 1/2 power plus 1/2, which we know 1/2 plus 1/2 is the same thing as 3 to the first power, which is 3. In the next property, we have a exponent being raised to another exponent. So in this case, we have a to the m power all being raised to the nth power. When we have a situation like this, we know that we're going to multiply our two exponents together. So let's look at an example. If we have 2 to the 3/2 power raised to the second power, what would we do here? Well, since 2/3, the exponent 2/3 is being raised again to the second power, we can make our outside exponent a fraction just like our inside exponent as 2/1. And because we're taking a power, raising it to another power, we can multiply these two together. So our base would still be 2. 3 times 2 is 6, divided by 2 times 1 is 2. We know 6 divided by 2 is the same thing as 3. So this whole thing simplifies to 2 to the 3rd power, which we know is 8. And the next property, we have the product of a, b, so we have two bases all being raised to the same power. So in this case, we can basically just distribute our mth power to both of our inside terms. So we get a to the m times b to the m. So in this example, we're going to take 9 times 4 raised to the 1/2 power. 9 times 4 to the 1/2 power, we can distribute the 1/2 power to each of our inside terms. So we get 9 to the 1/2 power times 4 to the 1/2 power. And if you remember from our previous videos, 9 to the 1/2 power is the same thing as the square root of 9. The square root of 9 is 3 times, well, 4 to the 1/2 power is the same thing as the square root of 4. So the square root of 4 is 2. 3 times 2 gives us 6. And the next property, we're taking a to the negative nth power. And anytime that we take a exponent, we have a negative, basically we're taking that base and exponent and flipping it to either our numerator and denominator, wherever it happens to be. So in this case, our negative exponent happens to be in the numerator, since we can write this as a fraction over 1. So to get rid of the negative, we're going to take the entire numerator, a to the mth power, and move it into the denominator, as long as our base is not equal to 0. So in this case, let's look at the example 16 to the negative 1/2 power. 16 to the negative 1/2 power is the same thing as writing this whole thing over 1, just like we did over here on the left. So we can take our exponent, the negative exponent, and flip it into the denominator. When we flip it, remember we have to remove the negative, since that's what the negative represents, is flipping it into the denominator. In this case, 1 over, well, 16 to the 1/2 power, just like the previous properties, is the same thing as the square root of 16, which we know is 4. So our answer is 1/4. In our next property, we're looking at a to the mth power divided by a to the nth power. And in this case, we have the same base for both of them. Our exponents are different numbers. We take our numerator exponent minus our denominator exponent, okay, as long as they're the same base for our fraction. So in this case, we have 5 to the 3/2 power divided by 5 to the 1/2 power. since we have the same base for both of these and we're using division, we can simply take our numerator exponent minus our denominator exponent. So we get 5 to the 3/2 minus 1/2. And we know 3/2 minus 1/2 is the same thing as 2 over 2, which we know is the same thing as 5 to the first power. So our answer to this property is 5. Our last property has same thing as the previous one, division. The difference is both of our bases, we have two different bases and they're being divided by each other, and we've got the whole thing being raised to the nth power. So in this case we can do the same thing as we did in the third property, and we can distribute that m to both pieces. So we get a to the nth power divided by b to the nth power, as long as our bottom base, our denominator base, is not equal to 0. So if we look at this example, let's look at 8 over 27, all raised to the 1/3 power. So we can distribute both of these, separate them, so 8 to the 1/3 power, 27 to the 1/3 power. Remember back to the previous videos, this is the same thing as looking at the cube root of 8 over the cube root of 27. Cube root of 8 is 2, cube root of 27 is 3. So our example for this property is 2/3.